On this DeBacco University video, I'm going to be going over the proper steps when it comes to balancing chemical equations, but I will preface this with saying this is something you simply just have to practice, but I'll try to give you 6 helpful steps to make the process a little bit easier. All right, so what is this balancing of equations? Well, we want to think about this and approach this kind of as a molecular puzzle. The goal is to make sure the number of atoms on both sides of the equation, the reactants and the products, essentially becomes equal. Because due to the law of conservation of mass, we can't create or destroy matter. So we have to account for an equal balance on both sides. And when things are going through chemical changes and we're having reactions occur, this might not seem as logical. When we're going through and just writing things out, we do have to maintain this balance on both sides of the equation to ensure we don't have more of one atom on one side compared to the other. So think about this again as like a puzzle, because you're going to take a little back and forth there to get this balancing act to occur. So some key terms that I'll be utilizing and you should be familiar with. The first one is going to be subscript, and this indicates the number of atoms that an element is present in the molecule or the compound. If no subscript is written, it is understood to be 1. Small numbers are written in the lower right of an element symbol in that chemical formula. So again, what does that look like? Well, right here we see the H2, in this case the O2 here. We do not write if there is just 1. So again, keep in mind this is called a subscript, and we see that indicated basically right over here. Number of atoms and elements present in the molecule. Then we get to the term coefficient. This is kind of the big number here, and this indicates the relative number of molecules or moles of a substance involved in a chemical reaction. A number is placed in front of the chemical formula in the chemical equation. Typically write that as the full size as we do the letter there for the corresponding element. Then we get to the formula, and that represents the composition of chemical compounds or molecules using symbols of elements and numerical subscripts to indicate the number of atoms in each element. So again, we see our subscript or coefficient in our formula. H2O is water. C6H12O6, that's glucose. So because we cannot change those formulas, we can only work with the balancing of those coefficients. So it might be very tempting to start changing the formulas or start changing the subscripts, but we are going to be balancing those coefficients. So we're going to use coefficients, again, as whole numbers to balance, and we never change those subscripts. We use the coefficients to be whole numbers to balance. It's very tempting, as I said, to change those subscripts. We cannot. A subscript change would actually change the actual compound, and of course that would not be allowed, because then we wouldn't be having the chemical equation that is before us there. Now, step 1, we want to write the correct chemical formula. So write the correct chemical formula for all reactants and products. Make sure to use formulas that are accurate before attempting to balance. Hopefully you remember your naming rules when it comes to maybe giving an equation that's written in the name form. You have to convert that to the formula. And you can see in this example, we've put lines here because those are where the coefficients are going to go. And as of right now, we're not exactly sure what those coefficients may be. We know what the reaction is. C7H16 plus oxygen is forming CO2 plus water, but how do we go about balancing this? So first off, write the proper chemical formula. Then we count the atoms of each element. You can present this different ways, but count the atoms of each element on both sides, the reactants and the products, and use a tally to see what elements need adjusting. So if we look at our example here, there are 7 carbons, there are 16 hydrogens, and there are 2 oxygens. On the product side, there's 1 carbon, 2 hydrogens, and essentially 3 oxygens. Now, why does it say 2 and 1? Well, there are 2 on this carbon dioxide. There's also 1 on this water, so 3 in total. Looking at these quick, none of these match up. So we've got to go through and balance this equation. We want to start with atoms that appear in only 1 compound on each side. So start with those atoms, again, that only appear on this 1 compound. It's often easiest to begin with metals or complex molecules. So as we can see here, we're going to start with carbon. We have carbon 7 and carbon 1. How can we balance the carbons? Well, we could put a 7 here as our coefficient, and now 1 times 7 gives us 7 carbons. However, we also have to keep in mind that 7 gets distributed out to the oxygens. So instead of just having those previous 3 oxygens, we now have 15. 14, because 7 times 2 is 14, plus the 1 there. So we still have some work to do to properly balance this. We want to count and balance the polyatomic ions together. Balance polyatomic ions as units if they appear unchanged on both sides. So looking at another example, we see SO4 here and SO4 here. Don't balance it as sulfur and oxygen separately. Balance it as SO4 because that polyatomic ion is carried over from reactants to products. Now, as we see, others might have oxygen as well. Well, this hydroxide group, we're going to go through and we're going to balance those as hydroxides. So when you think of polyatomic ions as individual elements when completing the chart. So again, group them together. Same thing we see here with SO4. Then we want to leave oxygen and hydrogen typically for last. So they often appear in multiple places and can complicate things early on. So in this case, we start with our carbons, then we're going to progress to our hydrogens and our oxygens. But typically we want to save those for last because as we know with both of these, they're on both sides and they're a mix. So oxygen, for example, is in carbon dioxide as well as water. So write down a coefficient. Start to balance our hydrogen. So we put 8 here. 8 times 2 would be 16. That balances out our hydrogens. We also have to distribute this 8, of course, to our oxygens, and when we do that, we now have 22 oxygens compared to only 2. So now, one more step. We want to check our work and go through and make sure everything is balanced, so that one more step is adding an 11 here. Because 11 times 2 would be 22, and we can recount every item and confirm now that this equation is essentially balanced. So we never write a 1, that's assumed to be there. But the proper balanced equation would be C7H16 plus 11 O2s forms 7 CO2s plus 8 H2Os. So again, as I said, a little complicated, might seem a little weird to kind of go back and forth and play with this a couple times, but going through some more examples, you can get more proficient at this, but following these basic steps will hopefully give you a good start to this balancing of equations.